Hi, I'm AI Matters, and I'm a data analyst with extensive experience working with data, models, machine learning, and business intelligence. I created this channel to share my passion of AI and data and its impacts on humanity. In today's video, I'm going to talk about machine learning algorithms. AI is rapidly shaping the world we live in, but how exactly does it work? Let's explore the algorithms that are used to make machines think and solve problems. First, though, what is machine learning? In simple terms, machine learning is a type of artificial intelligence that allows computers to learn from data instead of being explicitly programmed. Let's say we are trying to predict what the price of a stock will be tomorrow. One way might be to create a set of rules and conditions, also known as an algorithm, to figure out what the price should be. This could utilize information like today's open, close, maximum, and minimum price. Another factor could be the trading volume. If there is any important news events due to be released, and even the day of the week, so we could manually define a set of rules based on our understanding of how each variable will impact the price. With machine learning, we create a model through feeding the machine data and letting it formulate the rules on its own through analyzing patterns within the data. Then the model can be used to make predictions for the price of the stock. This is the key. The machine learned the algorithm by itself, and all we had to do was give it the data, so the whole process is to an extent automated. So why is machine learning so important? Because it powers things like your Netflix recommendations, self-driving cars, voice assistants like Siri and Alexa, and tools that detect fraud and diagnose diseases. Okay, now let's examine the most commonly used machine learning algorithms. Linear regression. Yep, believe it or not, plain old linear regression is technically a machine learning algorithm. Linear regression creates a line of best fit through the data. This uses a method called least squares and is one of the oldest statistical methods. It is by far the easiest to understand because we get coefficients explaining how the output is related to the input, and also how significant each input is in determining the outcome. Obviously, linear regression works best when the underlying patterns within the data are linear. However, since linear regression is robust to overfitting, it can also work well when the dataset has few observations and many variables to consider. Next, we have k-nearest neighbors, also known as KNN. Looks at the k-nearest data points and makes a prediction based on them. So this method is based on statistical similarity between observations. The similarity is measured by the Euclidean distance. The value of k is a parameter and needs to be optimized, and its value will depend on the data. For some datasets, only a small number of nearby observations will yield the optimum result. But if the data is noisy, a large value of k might be best. K-nearest neighbors was developed in the 1950s and is simple but effective. It works well with nonlinear data, but the data needs to be scaled first. Otherwise, certain features of the data will be overlooked by the model. An underlying assumption of k-nearest neighbors is that each feature will have the same impact on the outcome, hence the need for feature scaling. The third technique to cover is support vector machines. Support vector machines find the best boundary or plane that separates different classes of data. Think of it like drawing a line that puts red dots on one side and blue dots on the other, with maximum margin between them. To do this, support vector machines use basis functions that can be linear or nonlinear. Support vector machines emerged in the 1990s. They work well when there are many variables to consider, or the so-called feature space has a high dimensionality. Next, we have decision trees. Decision trees work like a flowchart. The model asks a series of yes or no questions to arrive at an outcome. Decision trees inherently model complex, nonlinear relationships quite well, but are prone to overfitting. This means that the model will perform well with examples that it has been trained on, but poorly with other data it hasn't seen. To reduce the chance of overfitting, we can limit the number of steps in the decision-making process. This could be through reducing the tree's depth or increasing the minimum number of observations that can sit at a leaf node. This process is appropriately known as pruning. An important application of decision trees is using many of them to create more powerful algorithms such as random forests or gradient-boosted machines. When the data is tabular or structured, gradient-boosted machines are considered to be the king of all algorithms and pretty much unbeatable in terms of performance. Finally, we will look at neural networks. Have you heard the term deep learning? Well, neural networks are the algorithms core to this field. The concept of neural networks dates back to the 1950s, but they really took off in the 2010s. Due to breakthroughs such as the transformer unit, which led to the development of ChatGPT, inspired by the human brain, they consist of layers of nodes or neurons that process data in multiple stages. Neural networks work the best with unstructured data, such as audio, video, and images, although they can work quite well with structured data too. As we move forward into the future, neural networks will continue to probably be the most important of all in terms of their impact on society. They are able to capture very deep, complex patterns, and their ability to work with a wide range of data formats makes them extremely flexible. One thing we touched on when covering some of the algorithms is the concept of overfitting. This is an important concept in machine learning, and more complex models tend to be more prone to overfitting than simpler ones which have underlying assumptions. So which is the best machine learning technique of all? It really does depend on your data set. So there you have it. Machine learning is everywhere, from your phone to your card at the doctor's office. And it's powered by some incredibly smart but understandable algorithms. What is your favorite machine learning algorithm and why? Tell me in the comments below, and don't forget to like and subscribe. Thanks for watching, and keep learning.